Okay, hi, I'm Dan at Todea. I'm on SRE at Elastic, and today I'm going to be speaking about GenAI applications in the serverless world. So we're going to be hearing a lot of GenAI probably today and tomorrow. Before I start, how many of you have already tested LLMs or played with AI assistants or chatbots? Perfect. Wow, so many hands. Okay, so today I'm going to be speaking or revisiting, let's say, on GenAI technologies and concepts. And I'm going to be demoing a very short use case on GenAI in observability. And I'm going to finish up with, let's say, the benefits and why are we using this in the DevOps world. So, as we all have seen in the last few years, couple of years or so, GenAI has hit mainstream. So we all have been playing with OpenAI, ChatGPT, and so on. So to have a bit of a context, right now we kind of like change the mentality little by little. So when we want to go on a web browser and start, searching for an answer, we're gonna want to have like interactive experience, like a conversation with as an answer. We don't want to have, the same traditional list of links when you click on it and they redirect you to a website. So in that regard, the user experience will change a lot as well. Then we're going to be seeing a lot in this year and going forward, like a lot of focus on the data safety and the privacy. Obviously, there are lots of legal implications. Okay, if AI is stealing your data or is not used properly, so everything will amount to that as well. And then we'll be hearing a lot, and we are hearing a lot about proper context for GenAI. That means basically that okay, you can have a lot of challenges around hallucinations, outdated training data, for example, because the models are not having the proper context to be trained for. So here it comes to use to have an improvement to AI text generation with techniques like retrieval augmented generation. That can provide LLMs with some proper context from proprietary data. Then we'll be seeing a lot of new LLMs coming up into shape and form. Many models will get better, will get more efficient, and will be more adapted to specific business needs or business objectives. And fifth but not the least, for developers, what does it mean? It means that we need to be upskilled. We need to have a lot more training on AI, on GenAI, LLMs, and so forth. So we're going to be seeing a lot of that training going further as well. So where does GenAI stand into relation with machine learning and LLMs? So probably already are very familiar with these notions by now. So GenAI is a substack of machine learning. And it's focused on AI algorithms that are designed to create high quality content like text, image, and audio. And as applications, we have seen a lot like chatbots, text, image, music generators. What we can do with LLMs? Well, with LLMs, pretty much kind of the same thing. They are focused on deep learning algorithms that can generate text. When it comes to machine learning, the transformer definition is a very important concept. So transformers basically are neural networks that learn context and meaning by tracking relationships in sequential data, like the words in the sentence. And basically, they can do a lot of tasks. So we've been using them, for example, when we go online and start searching for an answer on the search engines. We use them when we want to, let's say, detect trends and anomalies to prevent fraud. When we are, let's say, translating text or speech in real time. So basically, we are using transformers a lot. So The transformers come in very handy, once we start applying them in real life. So we'll see that a bit later. I wanted to take a short pause here to focus on the transformer architecture because it's interesting how it relates to the Gen AI overall. So transformer architecture was coined like in a very classic article, "Attention is all you need," back 7 years ago. So it's not something that new. And it's focused on two layers called the encoder layer and the decoder layer, which work with a couple of mechanisms. So the first mechanism is the self-attention, and the second one is called multi-headed attention. So what happens behind the scenes is that the transformer or the transformer architecture is focused basically on text, on translation, and it's gonna give an input and gonna create an output based on the task that is at hand. So, for example, we have like encoder models. Just some examples that are familiar, like Albert BERT, Electra Roberta. They are focused on tasks like sentence classification, named entity recognition, or extractive question answering. And then for the decoder model, you have examples like GPT, GPT-2, Transformer XL, that are focused on tasks like text generation. And for encoder-decoder model, you have examples like BART, T5, Marian, and BART that are focused on translation. Okay, so Gen AI architecture is focused on creating new content depending on the data that you're feeding. So it will create either image or document or audio, and is focused on vector representation and nearest neighbor architecture. We're going to be seeing that a bit later into more applied use cases. Why am I mentioning both these architectures? Is that they're used by AI assistants. So although they in theory, they serve different purposes, an AI assistant actually uses both architectures to actually do its work. Okay, so we are also pretty familiar, I'm pretty sure, like with prompt engineering. How are we interacting with AI assistants? How are we interacting, like, for example, with ChatGPT? So we are asking a question, and under the hood, the Gen AI mechanism works and tries to retrieve the information from the corpus of data that you have fed, and then it provides that specific answer. Whether you like it or not, you will ask a further question, you'll get a new query, and then the LLMs basically will try to redefine or to retrieve a new information for you. So it will be a back and forth of queries with the LLM and with the Gen AI mechanism. So I've been mentioning the retrieval augmented generation before as a mechanism. It's a technique that supplements text generation with information from private or proprietary data sources. So what happens is that it will start with an input query, then the retrieval model will grab the information from databases or external sources, and then the retrieved information will be convected into vectors in a high-dimensional space, which then are stored into a vector database. The retrieval model will rank the retrieved information based on its relevance to the input query, and the documents with the highest scores will get selected for further processing. Our use case here with RAG and ELSER, you're going to be seeing, once you start using RAG with proprietary models such as ELSER, you'll be seeing a boost in its performance. So ELSER basically is Elastic's natural language processing model for English semantic search, and this basically will make RAG mechanism improve its performance. So you see here in the chart different types of versions of ELSER. And then with the version 2 optimized, the RAG in this case works a lot better. So I have revisited some concepts and some technologies of GenAI. Now I'll be focusing on, let's say, the applications. So how we can use GenAI in real life. For me, SREs and DevOps engineers are pretty much like focused, I know, more than 85% of the time on investigation. So we all like to take a look at logs, analyze errors, events, traces, and so on, try to make sense of why this is happening. So we are pretty much like detectives in a way, trying to research, trying to provide the root cause for a specific incident. So GenAI will come in hand here in that regard. Will help us troubleshoot, will help us make sense more of the logs and of the tools that we have at hand. I wanted to present the use cases in observability because Elastic is also has like the observability stack, which is integrated in the use case of the observability AI assistant. And obviously, talking from a DevOps perspective, you can feed the observability AI assistant that specific data that you need in your investigation. So I'll be speaking about application performance. It's one use case, synthetic real user monitoring, then SLOs, logs, and metrics. Or, if you're at another spectrum of business, you can actually use different types of data like marketing, sales, logistics, and so forth. I'm going to present a short demo of an application that uses OpenTelemetry, and it's integrated with the observability stack and with AI Assistant. So we're going to be seeing also the help of AI Assistant here. So this is the OpenTelemetry demo that I'm using with the observability stack. I created some SLOs here that, in case they are violated, you can check and you could go inside the APM side where you see the exact performance of your service. In the APM section, you can check, for example, okay, how is my application performing? What are the errors? Where are the traces? What are the metadata that is interesting for my use case? Okay, you have an incident, what's happening? And let's say you're trying to figure out a bit, well, what is going to be helpful in your investigation. Well, you can try and link it directly with the observability AI assistant. So you can click the check there. It will give you directly some useful links. Why is this error happening? How is this connected with your application? And then it will provide you, some root causes for it, and it's gonna also be linked with a runbook, for example, or a GitHub issue that you have fed it in the training model. Then, if you want to find out even more, you're gonna interact directly with the Elastic AI assistant, and we'll pretty much break it down for you in some easy steps. Basically acting exactly like an assistant. Okay, you need to check this, try to run this, look a bit more at the metrics. And also if you want to see exactly step-by-step definition of a runbook, you can do that as well. So looks pretty easy, right? I mean, you don't need to do anything. You can just enjoy, take a coffee, come back, and then, oh, okay, I solved an incident. Well, obviously you can link it with other Elasticsearch connectors. Here is a huge list of use cases. So looks like we're out of the problem. So if an incident starts, you know where to who to call and what to do. So like I said, I'm just gonna basically just a summary of the demo. It's a bit like case by case. So this is basically Elastic Assistant interacting with the alert analysis. So I'm asking, okay, I have no idea about this alert, for instance. Can you give me a list when it was triggering or what it was doing? Okay, it will give you a list of the alerts that are happening. And then if I want to, have some information on the troubleshooting steps, okay, well, what is happening with this alert? Can you give me, the proper step-by-step instructions, what I need to check? And it will give you that. Monitor, check the logs, modify the source, etc. Then if you have been using it with an SLO, like I said previously, you can do that as well. I want to check a specific SLO. I want to check the current states. And I also want to be able to create something new. So how to create a percentile 99 SLO, for example. Okay, I know. I need to do this, this, and this. How does it blend in a serverless architecture as well? You have some interesting guidelines, step-by-step definitions. You've seen also in the demo how to use it with the APM. So as well, an application here with a serverless proxy, you can see exactly how your application is performing, when it alerted the last time, etc. And also you have a cool graph as well in regards to the latency. So this is the part of GenAI actually working, the GenAI architecture working behind the scenes. You have the image that is being generated here alongside the transformer model. With the synthetics monitoring, for example, because I was mentioning this use case before, you can have different information on the monitors. So if they're active, if they're down, you have more information about that as well. So let's say if you are really techie and you want to learn more about how Elastic AI Assistant is under the hood. Well, it's actually working with Amazon Bedrock, technology with Claude version 2, actual LLM. Why Claude? Well, because it's kind of reliable. It's working very nice with logs, with log analysis. It's capable of creative content generation, of complex reasoning, coding, detailed extraction. It reduces also the brand risk, and it's very good for security log analysis as well. Obviously, you can use another connector if you want to, so you can use also Azure OpenAI at the moment. So you have that option as well. Ezra in this chart actually represents the Elasticsearch relevance engine. That's basically relevance tools for developing advanced search application using machine learning and AI. So something like very specific for this context. If you want to, let's say, try and use your own applications, or you're just starting, like many of you have did, and want to play more with Elasticsearch LLMs, you can check this repo. It's called Elasticsearch Labs. That contains executable Python notebooks, sample apps, resources, and also it's integrated with projects like OpenAI, Hugging Face, LangChain, so you can test it out later if you want to. So I've been mentioning the AI assistant parts on serverless. Well, Elastic AI Assistant works with serverless at the moment, but obviously you can any organization is very different, and some of the benefits are focused on this couple of points. So why is it beneficial? Because it can work as a function, as a service. So you can use that and many platforms like AWS, Lambda, Google Cloud Functions, Azure Functions. There are just a couple of examples for this kind. They scale really well. So in case you have multiple users that interact with an AI assistant, then in the same time, obviously, it will be very good from the cloud provider perspective to allocate resources to handle the increased workload. So that's one benefit as well. And then there is the cost effectiveness. because you use on the serverless platform, on the serverless architecture, you use a pay-per-use pricing model. In that sense, kind of like brings down the infrastructure costs. Not the least, also another benefit is event-driven architecture. So again, it will work like with the functions, we'll be triggering various events like HTTP requests or scheduled events. And not least, or you can use it on many other use cases, and just I'm enumerating some of the benefits. So, where's next with GenAI? Whether you have integrated or not, or your organization is integrating it at the moment, you have a lot of use cases for it. But you also have to consider some of the challenges as well. Mentioned at the beginning, some of the legal parts, some of can be also in the ethical side. Okay, will it steal my job? Will it not steal my job? That's something to be debated. Anyway, as developers, we always kind of like think forward. We are like practical persons, so we also try to experiment with new technologies. So in the case of developers, based on a recent survey Elastic conducted, proves that around 87% of developers already used GenAI, but only 11% used it or integrated it in productive environments. And why? Because it looks like some of these challenges appeared, like preparing your private data to use with GenAI, or upskilling technical teams, or training a proprietary model, or integrating it with LLMs or GenAI stack, or infrastructure costs. So in that sense, I'm talking about serverless that can be a good alternative to bring down some of the infrastructure costs. About the other side, obviously, you need to spend more time upskilling and trying to find the best use case for your organization. When it comes to the vector search engine, as well, there are some considerations you want to take in mind. For example, like reliability, cost, operational simplicity, ease of use for developers, and pre-latency. I'm just gonna wrap it up here with a couple of thoughts. Obviously, you want to be spending a lot more time discussing your use cases or even your personal feedback with the machine learning teams, with the data scientists in your company, or if you don't have such teams, just spend more time giving feedback to each other. Why you want to use GenAI, which LLMs will best fit your scope, your objective, and where do you see yourself, if you're going to see yourself benefiting or not from these use cases. It's not something that you're just going to jump into and start using it just because, it's there and it's very fashionable. So you need to be very pragmatic about the decision you're going to make. And as SREs and DevOps engineers, also, I think it's very good to explain why do you want to use that. Why does it help you in your troubleshooting? What do you want to see more integrated that will help you in your daily tasks? So that's something to keep in mind as well. I prepared a list of resources for you. If you want to check out the Open Demo repo or the application, if you also want to check out the Elasticsearch Labs, you have the repo as well. You have some documentation there to help you get started. Actually, this blog is really, really rich in technical documentation. So you want to take a look at that. They're written by machine learning engineers, and they can tend to be actually very advanced. Right? If you want to give your feedback, you can use the QR code there. I will link you to just basically put a question or give a comment. Thank you very much for your attention. I think we have time for some questions.
Do we have any questions? Oh, Perfect. What is a vector database?
Right, okay.
Great question.
Let's go back to I think, sorry, was here. Yeah. Right. Vector database is basically where these vector representations are being stored to. So a generative AI, or let's say the mechanism of generative AI, works pretty much with the nearest neighbor. So we'll try to vector out where to look for information. And that specific information is stored into the vector database. For example, Elastic has this vector database that is used in the ELSER mechanism that I was talking before. So this basically how it pans out is just another way for it to find for the information. Using the vector representation and the database is another form of storage. Obviously, I'm not going to explain it like a machine learning person, so I'm being pretty much simple or simplistic about my explanation. But yeah, in very shallow terms, this is how it works. Obviously how, because I was mentioning also the retrieval augmented generation, here is a bit explained. Like the retrieved information number 3 is converted into vectors, and then they are stored in the vector database. So basically, it's just like a map, that GenAI uses to search for information. And because it works with the nearest neighbor, it's kind of like trying to figure out, okay, how is this information linked into a vector high-dimensional space. Obviously, we can chat a bit later if you want. Obviously, there are a lot more resources that go much in depth than what I explained. And like I said, they tend to be a lot more technical. So, yeah, thank you.
Yeah, and I'm having GenAI open space. So that sounds like a great question. Yeah, we got GenAI on the board, so my day is complete. Any other questions? Oh, we got more questions. Got to run.
Well, we all know that software engineers are notoriously bad in creating documentation. Can the generative AI create good answers from the bad documentation of my company?
Yeah, I mean, what I like to say is like you're as good. Your GenAI is only as good as yourself. If you're gonna ask them like bad questions, or you don't know how to frame it, that specific question, it will just give you random or maybe incorrect answers, or not incorrect, but like not the complete version. So it will only work as long as you as an engineer work with the ML team, in the sense that you're pretty much gonna be responsible into feeding that information into the GenAI mechanism. They will do it for you in a way that it's a lot more smart and they know how to do it for you. But obviously, if you are the responsible stakeholder for that documentation, and it fails to be the correct one, you'll be fed incorrect information. So it's a mechanism. It only works as well as you feed the proper data into it. Just like ChatGPT, you're going to ask a question and then you're going to answer, oh, when I was last trained back in 2022. So it's the same. You're going to be using the information that you have fed. So you need to constantly be able to update that information, check it. So it's not going to steal your job. It's only going to make it better, as long as you yourself, are going to feed it the good information.